Hello dear students. In this module, we are going to discuss about some MCQs based upon Kirchhoff's law. So without wasting a single second, let's try to solve our first question. So the question says, the Kirchhoff's first law, that is summation I equal to 0, and second law, that is summation IR equal to summation E, are respectively based upon conservations of. Now, when you talk about this word conservations, conservation means the given quantity should be equal before and after some process. So let's try to focus on the options: charge and momentum, energy charge, momentum charge, charge and energy. Now let's try to analyze what is Kirchhoff's first law. Kirchhoff's first law is nothing but the based upon incoming current should be equal to outgoing current. So when you talk about current, it is nothing but flow of charge. And yes, you guessed it right, it is nothing but the conservation of charge. Now when you say incoming current should be equal to outgoing current, implies there is neither gain nor loss of charges at the given junction. So our first option, that is charge, that means option B and option C are eliminated. Now let's try to talk about the Kirchhoff's second law. When you say the Kirchhoff's second law, it is purely in accordance with the conservation of energy. Why? It's very simple, dear students. Summation IR represents the total energy spent in sending a unit charge around the circuit, whereas summation E represents the total energy supplied by the sources of EMF. Hence, my correct option is option number D. Moving ahead with a beautiful question. The question says, in the given circuit, the current in 8 ohm resistance is 1.5 ampere. Okay, so I name that current to be I1 equal to 1.5 amp. And what is the total current flowing in the circuit? So if you see, dear students, 8 ohm and 3 ohm are parallel, right? So the current, let's assume to be I, is flowing in the circuit, and I'm supposed to find that current I. But can you see, dear students, I will be nothing but the combination of I1 plus I2. Yes, by using KCL, because incoming current should be equal to outgoing current. How do I solve this? It's very simple, dear students. Can I say these two resistances are in parallel? Yes. If the resistances are parallel, then by the Ohm's law, I can easily say that the potential across 8 ohm resistance and the potential across 3 ohm resistance will remain same. Yes, dear students. So if the potential or the voltage remains same, I can easily say by Ohm's law, I1 R1 should be equal to I2 R2. And what I am knowing this, I know I1, that is given to you in the right hand side of the screen. I know R1, I know R2, I can easily find I2. So when I find I2 I'll get is equal to 4 ampere. But I am supposed to find I. Yes, I will be nothing but I1 plus I2, that is 4 ampere plus 1.5 ampere. So when I add these two quantities, dear students, what I get is the correct answer to be 5.5 ampere. Perfect. Moving ahead with our last question for this module. Again, a beautiful question. The question says, when the switch S is closed in the following circuit, the current passing through the branch BD is. Now, dear students, let's analyze this circuit. When you see this circuit, dear students, there is no current flowing through the branch BD right now. Why? Because the key, that is S, is open. So when I just close, there will be definitely some current flowing through it. So let V be the potential at point B. Why? Because I require potential to find current. So when I assume the potential at point B and I just close my switch. Yes, dear students, can you see the switch got closed? Now there will be definitely a flow of current. So since the potential at A and C are 20 and 5 volts respectively, let's assume I1 flowing from point A and I2 flowing from point C. Now they come together and meet at point B. So can I say at point B, I3 will flow down, which is nothing but the combination of I1 plus I2. Perfect. Again KCL. Incoming currents should be equal to outgoing current. Now according to Ohm's law, what should be I1? I1 should be the potential drop across AB upon the resistance. Perfect. What should be I2? Yes, it has to be the potential drop across CB upon the resistance. And what should be I3? Yes, I3 should be the potential drop across BD upon the resistance. So when I multiply the equation by 4, what I'll get is 40 minus 2V plus 5 minus V comes out to be 2 volts. That 2V can be easily taken to the LHS, and once I simplify, what I get is potential at point B is equal to 9 volts. Do I require this? No, I don't require this. What I require is I3. Now what is I3? Yes dear students, you can see I3 is nothing but V by 2, and hence the correct answer will be 9 by 2. That comes out to be 4.5 ampere. That means option A is correct. Thank you for this module.